Alright, we're back with ENGR1020 MATLAB. This is our 4th week now, I guess. Sounds right, 4th week. And we've covered a lot of stuff so far. We're now going to be moving on to the manipulating MATLAB matrices, playing around with arrays essentially. We're going to learn some ways to search through matrices, to create new things. I mean, we're going to do a lot of different stuff today, and then I will upload a homework for you as soon as I can. I'm sorry that we're a little behind. This has actually been kind of a crazy week in North Platte because of some crazy weather. We've missed a couple days of school, including the day that I normally do this. So I'm going to go ahead and get started with this. And let's see where we can take it. So, manipulating MATLAB matrices. Of course, remember to take notes in a M file and submit that in your homework assignment for this class today, showing that you went through and did what we did. First of all, we're going to start off with just a review of how we build matrices to remember how that's done. So for example, if I wanted to start off with a matrix called A, or an array called A, here we go. I assign it to the letter capital A, for example, and I can put down some square brackets, and then I can start entering in numbers. I can enter in a single number and create a matrix that way, and if I wanted to print out to the screen, I could just print it out to the screen like that. If I didn't want to print it out to the screen, I go ahead and put down a semicolon, and it won't print out to the screen. It'll just save it over here in my command history. And you can see my command history is actually quite full right now. I think I want to actually clear that out. Let's do clear all. For some reason my computer is working very slowly. Well, that's my command history. I want to see my workspace. So my workspace is clear now. So if I go back up here to A, it should save that in my workspace. There it is, A, and it's just a single row, single column, one matrix, one entry, one element of the matrix. Then of course I can build bigger matrices if I want to, and if I want to separate rows and columns and everything else, then I start to use I can use spaces or commas or semicolons in here. So for example, if let's make the matrix C, and let's go ahead and let's do that right, there we go. Let's make C equal to -1, and then I can put a comma, and I can put a 0 and a comma and a 0, and then I can actually put a semicolon. If I put a semicolon in there, then I can put a 1 and a comma, and 1 and a comma and a 1 and a comma and a 0 and a semicolon. I keep putting colons instead of semicolons. There we go. I don't know why it's taking so long for these commands to go through. And that gives me a matrix. I can also do a similar thing, but instead of doing this all in one row, I could take this part of it and I could put it, goodness gracious, I could put this down below it here. Slow computer for some reason, I don't know why. But I could build it on two separate rows so that I know that it's two separate rows, and that's fine too. It'll still read it the same way, and that's perfectly fine. I can also just leave the colons off. So if I do this previous command here, I go out up here and copy this, for example, and I put it here. And I leave the semicolons off here, and don't need one there anyway. But if I leave those off, it recognizes the next line as a new row when I put it in. And I can also actually leave spaces in here instead of commas. MATLAB understands that in the same way as it does commas. So there's a lot of different ways to enter them in, and actually there are certain advantages to one way over another way that you learn as you go and do more advanced things in MATLAB. It's not important to us at this moment, but there are a lot of things to learn about how MATLAB can work and how you can make it do things. Then if we have a matrix now that is some big matrix, we can start to call out certain elements of that matrix, or certain numbers that are in certain positions of that matrix. The first number, remember, is the row. The second one is the column. So if I look at the matrix C, for example, this is the matrix capital C, and I put some parentheses after my C here, and inside the parentheses I put the number 1, 6. That'll bring back the element of C that is in row 1, column 6. And if I go ahead and enter that, we're going to see that there's no index 6 in our C, in our matrix C, because I only have 3 columns. So if I want to do something inside of this matrix, I need to pick something that I've got, which is, I could do row 1, column 3, for example. Let's see what that brings back. So that's going to call up the number 0, because in row 1, column 3, that's this element right here, that is the element that is 0. So you can also change it. For example, if I wanted to change that one, then I could say C13 equals 34 or 35. And I can go ahead and put that in there. And now when I call up C, it brings up 35 in that position. So you can change individual things inside of the matrix. This becomes extremely useful. You can build this huge array of numbers, and then you can do some operations, do some math, and change individual things out and call individual things out. And you can use some things that you call out to calculate other things that you're going to put back in. You can use the array as a big organizational structure for all these numbers. And that's kind of what we're getting to. So that's one thing that you can do with your matrices. And of course, if you just have one single long thing, for let's say that we have, let's do a random, let's call it R equals random, goodness, I can't keep my computer doing what I want to do. Let's do a random 28 by 28 matrix or something like this, right? If I build a random 28 by 28 matrix, it's going to build this big matrix with all these numbers in it. Excuse me. Then I can start to search for things in here. I can search for numbers that are in between, and I think that we did a little bit of this last time, but I can start to see what I've put in here, right? So so that's enough of a review of the things that we know so far, I think. And now what I would like to do is to learn more about the colon operator. Remember when we used the colon operator before, we would make a matrix, call it B, for example, and we would say that B is equal to 1 by steps of 0.001 to 50 or something like this, 40, right? So you can create this array of numbers that when I press enter, it creates every number between 1 and 40 in steps of 0.001. So it's creating this huge array. It becomes quite big. And let's see, B ends up being 39,001 entries. So this is just a really huge thing. And that's the only way that we've really used the colon in MATLAB. However, the colon has another use that's quite useful. So, for example, remember that rows are the first number and columns are the second number when we start calling things. So if I go back to my matrix C and I want to call out, let's say that I want to call out the first row and the first column, that element right there, C11, I hit enter, it calls it up, it brings up the number -1, and that's great. But what if I wanted to call the entire first column? When you want to call the entire first column, then what you do is you use C again with our parentheses, and we want a capital C here. So a capital C with our parentheses, and we want column 1, so we're going to do comma 1, but in the place where we would normally put the number for the rows, we're going to use not the semicolon, but the colon, where the colon means all of. So you're taking all of the rows and the first column. And when I call up all of the rows in the first column, I'm going to get all of the numbers that are in the first column of that matrix. So it makes it very easy to call up a column. You can also do this with rows. If I wanted to call up the entire second row of C, then I would go ahead and do the second row, comma, all of the columns with the colon rather, and hit enter, and it will bring up the entire second row and all of the columns right there. So the colon operator can be very useful if you need to get an array of numbers from, extract an array of numbers from a matrix. We can also use the colon operator to extract parts of columns and parts of rows. And the way that we do that is, well, first of all, we're going to have to build a bigger matrix. So let's build a bigger matrix, M, and let's let M equal some random matrix. Let's say 9 by 9. Let's multiply that by let's multiply it by 10, and let's go ahead and put a ceiling on this. So we're going to round all these up. We'll round all these numbers up so that we have a bunch of whole numbers. Just makes it nice and clean for what we're doing. Hopefully that gives me what I want. Remember, we did these things last time. So there's my random array of numbers, a 9 by 9 matrix. And let's say that I would like to have everything between rows 4 and 7 in all the columns. So I want to get essentially let's see here. I want to get, what do I want to do? Let's say I'm going to try to get everything in rows 4 and 7. There we go. And between rows 4 and 7 and all the columns. Well, that's fine. Let's just do that. So M, and we're going to put in our parentheses again, because the parentheses just tell us that we're taking one of the elements from M, or several of the elements from M. What I'm going to do is for rows, I'm going to do 4:7, and then I'm going to put comma. So that's essentially the rows that I'm interested in from 4 to 7, everything from 4 to 7. And then I want all of the columns. I just put down my colon for all of them. Excuse me. Bring this up, and it's going to extract an array of numbers between 4 and 7. So it has rows right here, 4, 5, 6, and 7, and it has all of the columns. 4, 5, 6, and 7 are all of the columns. If I wanted to do all of the rows and just some of the columns, so if I did all the rows, I put my colon and then I put comma, and let's do 1 through 3 in the rows. Or sorry, 1 through 3 in the columns. Then this is going to give me all the rows, but only 3 columns, right? Only the first 3 columns, 1 through 3. Excuse me. So this can be an extremely useful tool to extract a part of an array. Maybe different parts of the array are used for different things in your sorry, I just lost my train of thought. Maybe different parts of your array are used for different parts in your program or different parts in your mathematical computations. So you want to split it up and you want to be able to use them in different ways, and that's perfectly fine. You can use that, and you can actually move through the array in different ways, and that can be extremely useful as we go forward. So, what are some other commands that we can use? If you want to, you can actually change the array. Let's change the array using the colon operator. If you do m parentheses with just one colon in the middle, what it's going to do is it's going to put all of the rows into one, actually all of the columns into one big long column. So let's see what that does for us here. Excuse me. There we go. One big long column. And m is still preserved. It didn't really change what m is. It just wrote everything down as a single long column. If I type in m and hit enter, it still will bring it up as a 9 by 9 matrix, just like I built it to begin with. So it hasn't changed what m is, it's just displayed it differently. But that can be useful as well. So for example, I can do m list, and I can transform my m column into another, put it into another variable, put it into another thing here in the computer, another array. But instead of being 9 by 9, I create my own little list of things here, if I can get it done right. I think I'm trying to work too quickly here. And so now I have another variable over here, which is my array of numbers, but just listed out in one long column. Other things that we can do with this. Another thing I can do is I can find things at the end. For example, if I have m and I want to find the thing at the end of the first row, the element in the first row, but the end column, and if I don't know how many columns it is, then I can just go ahead and put m1 comma end, and it'll pick the last thing, the thing that's in the last column of the first row. You can also do m end comma end, like that. And it'll find the last column in the last row, essentially the bottom right corner of the array. And there are many other things that we can do with this as well. That's just kind of the beginning of it. So, I know that we also have before entered in data from other sources, and I want to remind us how we do that. So what I'm going to do is I'm going to try to find a let's see here. Here's my MATLAB folder. We're going to try to find something to import here, maybe. Let's go to desktop. See if we can find it here. Can't seem to find a file here. I'm going to look another place. I'm going to look right here. Not it either. Maybe I can't find it anywhere. There we go. Okay, so if you have a file that is a MATLAB file somewhere on your computer, or if you're uploading one from the internet or uploading one from Blackboard that I give to you, which I will do, then you can import it into MATLAB a couple of different ways. So if I go here to let's go here to materials, and I've got some folders in here. Let's actually go back here. Let's see, we're going to be in this. Let's see if we can find one in here. Here are some files we've got. I don't know what this one is, but let's open it up. So this looks like a good file. It's got a whole bunch of numbers in it. Some of them are obviously delineated somehow. It's got a lot of data in it, lots of things to do in it. So we can go ahead and import this. And there's a couple of ways to do this. This is a text file as it is right now, but we can change it into something else if we need to. Excuse me. Let's go back here to our home and let's import the data. So we can do this is one way to do this. You can import data. So I can come over here to, oh, it's not going to like that one. We have to change it first. So what I'm going to do is I'm going to come up here and I'm going to click on this, and I'm going to go do a save as. And hopefully it'll let me do that. I'm not seeing my, there we go, save. I'm going to save this as, instead of a text file, I'm going to change it to a mat file. And then when I go to import data, it should let me do that. So ashfield.matlab, I open that up, and it's what it's actually doing is it's actually going to load this file as an array of numbers. Now it's giving me an error right here, error using load. So the other way that we could do this is we could use the load function. If you want to know how to use that, just do help load, but it's essentially, we showed you this before, and you can learn how to load functions using this help guide here. But let's look at this error. It says number of columns on line 5 of ASCII file. This is the file that we're looking at, this one. It must be the same as the previous lines. And you can see here in line 5, we've got this shift in the data. There's an extra column in here for some reason, and it's shifted over. And so the data has been messed up somehow in the original file so that they don't line up properly. It looks like these were supposed to be somewhere else maybe, but the file is certainly corrupted in some way. And that happens quite a bit with data files. In that case, you need to get in, you need to edit the data file. And you can do that by just getting in here and changing things around, moving some stuff around. Maybe these things just need to be pulled out or something. We need to put some things in these columns. Whatever it is, you can get in there and you can fix it. So for example, if I come in here and I hit tab right here, that moves all those over, and then if I hit delete here, it's going to move things over, and I can start adjusting things. But you have to be careful when you're dealing with data files, because the positions of these numbers is important. You have to remember why they're in the position they're in and get them back into the correct position. Sometimes it's easier to just go back to the beginning and start over with a new file, which is what I'm going to do. But that is the idea there behind loading a file. If you need to load it into a particular folder so that you can use it with other things that you're doing, then you need to make sure that you're taking that file and moving it to another folder, copying it to another folder. So for example, if I want to, if I go here, see if I can find here's a .dat file, which is a data file that you can open up in MATLAB. You should be able to open up in MATLAB. Let's change it to a .mat file, because that can be definitely opened in MATLAB. Let's open it up and see what happens. You can see down here that it's given us the command load weight.mat. And of course my computer is being slow and I don't know why. Oh, here it is, it's loaded it already. Let's go ahead over here and open it up. And it looks like it's a 100, it's just got 100 numbers in it. It's a 100, we can open up the actual file and see there's just 100 numbers in 100 different places in here, and that's great, no big deal. But if we actually wanted to use this file with for example these other variables in a workspace, I would need to save this file in the same workspace these are at. So one way to do that is to just right click on this and make a copy of it. Go ahead and copy that file and then go back to my previous workspace. So I can just go ahead and push these back buttons till I get back to where I started, which was a little ways back here. It's probably right about there. So I'm back in my MATLAB folder and I can go ahead and right click here and I can paste that file in here. And now that file is in the folder that I'm working in, so I can use it and I can call it and I can load it. When I hit down here, if I go ahead and type in weight, into MATLAB, it should know what it is. And there it is, 100 lines of weights. So just things to remember, a little bit of review there. Let's take a look at, I think that I've got some decent temperature data here we can look up. Let me see if I can find it really quick. Let's see, I'll find a better one here. Alright, so I've got some decent data here. I'm going to bring this one over here and drop it in here. So I'm just dragging something over into this file from my Finder window or my Windows window, whatever you want to call it. I just found it and dragged it over and put it in this workspace. Now I've got this other thing in here called sensor.mat, and I can go ahead down here into my command window. And I can put load, can use the load command where I load quote, single quote, sensor, close that single quote, and I have to actually put a .mat in there as well. So load sensor.mat, and over here we should see it show up in our workspace. So it shows up as sensor, so now I can use it. And it's a 20 by 6 array, so it's got 20 rows and 6 columns, a bunch of sensor data. And I can go ahead and use that for different things. Let's see, what can we use this for? So let's, this sensor data is essentially, these are essentially sensor readings that have been taken from, let's see, it looks like 20 readings per day for 6 days, it looks like. So each day is a different column. Each column, each day is a different column, and each row is a different time of day. And they take these sensor readings, and they can be just about anything, really. But let's say that I'm only interested in the sensor readings on the 3rd and the 4th day, the middle 2 days of the study. So I can go ahead and through here, and I can extract those by taking sensor and using my parentheses. And I want to do all of the rows, so all of the sensor readings. So you put my colon down there, but I want to do 3:4. I want to just extract those 2 days. Go ahead and pull those out, and you can see I've got 40 numbers here in 2 columns. So all my sensor readings, whatever they mean. I don't know what these sensor readings are for, but they are sensor readings. Then if I wanted to, let's say that these sensor readings needed to be calibrated, and there's some kind of a calibration. So if I have a calibration, my calibration equation could be entered in here. I could take that answer there, for example, and multiply it by whatever it is I need to multiply it by. Maybe I need to multiply it by 8.123 or whatever. And then maybe I need to subtract off 5 from that, and maybe that's my calibration right there. Whatever it is, I can do that, and it will fix these numbers the way they need to be fixed, right? Multiply by 8.123 and then subtract 5, and then all of a sudden that is calibrated. This is used all the time in engineering and science. You have, for example, this past summer I did some work for a company out of California that does agricultural research, and I was picking corn and soybeans and sorghum and other things, and we were using a sensor that could tell us what the moisture content is of the grain, and that moisture content needed to be calibrated constantly. And the calibration is something like this. You've got all these numbers that are coming in and out of the machine, and you are doing some simple math on them usually, but you have to do the math on a lot of them at once. So this is where MATLAB becomes very useful and helpful. All right, so the next one of the next things that you can do a lot of with MATLAB is to solve problems, and specifically to solve linear algebra problems. But I'm going to skip that idea because you don't necessarily have a lot of experience with linear algebra. But essentially what it comes down to is building a matrix, what is called it's an elongated matrix, and I can't remember the name of it called anyway. But anyway, it's a matrix that has all of the coefficients of the equations that you're trying to solve if you have multiple variables and multiple equations, and then using MATLAB to reduce that matrix down into some kind of row echelon form so that you can read off the solution. And it does that very well. However, since it is a little bit outside of the math required for this course, we're going to just kind of skip it a little bit, but we do want to look and see what MATLAB can do in things that are related to this somewhat. So let's find an example here. I need to find an example let's do an example that kind of uses these ideas a little bit. So anyway, everyone knows that when you're looking out towards the horizon, that you can see a certain distance before you're essentially looking off the end of the world, right? And you can only see so far to the horizon before the curvature of the Earth essentially takes the horizon away. And it kind of depends on how high you are standing, but it also depends on the radius of the Earth. And it turns out that the distance to the horizon follows an equation that looks like this. Distance equals the square root of the height that you are above the ground squared. See, is that the height above the ground, or the height from the, I think that is the height above the ground, plus, this is all inside the square root, plus 2 times the radius of the planet you're standing on times the height that you are standing above the ground. So that is the equation that tells you how far it is to the horizon for a particular person standing on a planet. But this equation is good for any planet, not just the Earth. You just need to know the radius of the planet, r, right there. And so what we're going to do is we're going to build a matrix. We're going to solve the problem that tells us how far we are away from the horizon, or how far the horizon is away from us, if we're standing at different heights on the Earth, or if we're standing at different heights on the Moon. 2 different places, right? So it turns out that the radius of the Moon. So we're gonna first thing I'm gonna do before I move any further is erase this equation until I get some better stuff down here. So first thing I'm gonna call the radius of the Moon Rm, and that's gonna equal, turns out 1,737 kilometers. Radius of the Moon. Radius of Earth, if I can get it to work here. There we go. I don't know why my computer is so slow. 6,378 kilometers. Okay. Now, the height of the mountains on Earth are between 0 and 8,000 meters. Somewhere in that range. And so we're going to use that as our h. So we're going to go ahead and use h equals, and we're going to start at 0. We're going to go to 1,000 in steps of 10. That should be, I think, sufficient. And actually, I'm going to go ahead and start at 0. I did start at 0. Good. So 0 by steps of 10 to 1,000. That should give us an array of about 100 numbers, right? Let's see if we've got it right. H is 101. Close enough. Okay, so now we can go ahead and start to build a MATLAB solution here. First of all, we want to go ahead and find, let's go ahead and do this in an M file. Let's open a new M file. New script. And this is my example, whatever it is. Horizon example. We're going to find the distance to the horizons of Earth and Moon at different heights. Sound good? Okay, so we know what we're doing now. We'll go ahead and define our Moon and our Earth. We could do that again. I'm not going to because I already defined them. They're already in my workspace. But when you're writing your script, you should do that for sure. And what I've got here now is an equation that I'm going to enter in here, and that equation was, let's see, it was distance equals square root, and we want to have the h squared. We already have our h, right? And then we want to add on to that, was it adding? Where is my equation? Can't find my equation. There we go, yes. So we're going to add to that 2 times h times r. Right? So 2 times h times r. And then we close that square root. And that is what our distance formula is going to look like. But remember that we've defined our Earth here, and we've defined height here, right? but we have two R's, and neither of these are, and this R is not correct. We need, this is R Earth, for example. So I need to make two different things here. I need to make distance to Earth with R Earth in this equation and H, and that should work. So I'm going to go ahead and close that off. Whoops. Semicolon. And then let's do distance to Moon. And distance to Moon will be a very similar thing. It's going to be the same equation essentially. I'm just going to copy this, paste it here. I'm just going to put R Moon on the end. We're good to go. There is one problem here, and that is conversion. I'm using for my R Earth and R Moon, I'm using kilometers, but for my height, I'm using meters. I should probably change that. So I'm going to change my H down here in my workspace. I'm going to change that from 0, and I'm going to go by ones. Well, let's actually just change our R's. Let's put those up here. I'm going to go ahead and insert these right here. I'm just going to start and do this right. So the radius of the Moon is going to equal whatever it's equal to, 1737, but that's in kilometers, so I'm going to add 3 zeros to it, and that's now meters. So just adding 3 zeros to it, and I can put a little note here that this is 1,737 kilometers, right? Which is the same as this number of meters, which is 1,000,000 meters, 1,737,000 meters. And then I'm going to go ahead and put in radius of Earth equals 6378. 6378, add 3 zeros, same thing. So then I've got my distance to the Earth, distance to the Moon, horizons, both calculated separately. And then I can go ahead down here at the bottom, and I can say I'm going to create a table, right? And stop my caps lock thing, what's that all about? And then I'll put in, I'll say D, comma DM, make that into an array. Right? Then I can go ahead and run. I'm going to save this first. Whenever you do this stuff, you should save it. I'm going to call this the Moon. And I'm going to go ahead and run it. See what I get. So obviously it's been able to save these two numbers here, but I've got this problem with using the little caret here because I tried to square my H, which is an array. And remember, when you square an array, you have to square element by element. So it has to be dot squared. You have to put that in there. So we go ahead and fix that. We save it. We run it. And looks like it's giving me some numbers. It looks like, though, it's giving me 16 columns. If I look on here, if I look to my table here, which is going to come in under answer, I guess it gives me a 1 by 202 table, which is not what I wanted. So I think that I want to put these things in different columns here, and let's try that. Let's go ahead and save it and run it. Still giving me a lot of columns. And I think I've made my numbers too small. I think I've made too many numbers to do this. I think I want to make my H smaller. Let's go up in here and define H again. So we'll let H, just reverting back to my other coding days here. Let's let H equal, now that we're going between, let's go between 0 and, let's go by hundreds, maybe. No, let's go by thousands. So between 0 and 8,000 by thousands. And let's go ahead and make sure these don't print to the thing anymore, and we'll go ahead and see how we do here. And this is often how you run these programs. You just kind of build yourself a build yourself some code, run it and see what's wrong and try to fix it. So now I've got 2 rows, but I actually want 2 columns. And let's see if I can do that just by putting a little apostrophe on here. I think I can just by inverting that thing. So I'll save it and run it. And there I got 2 columns now, distance to the horizon. You can notice that it's 1.0 times 10 to the 5th meters here. So it's 10,000 meters times these numbers, or 100,000 meters times these numbers. So it's on the order of 50 miles, 60 miles to the horizon, as many as 100 miles to the horizon in some cases, depending on how high you are above the ground. You can see a lot further. So anyway, that's that example. We've got other things that we can do here that we should try to do. Let's that's not any different, so I want to do another example that's the same. Okay, let's take a look at, we're actually almost done for today. I haven't even been on for that long. But all the stuff that we need to do today is we're kind of repeating some things that we did in the last chapter. If I'm remembering correctly, I'm just going back and taking a look at some of these things. They're all very similar. But anyway, let's take a look at some of the different special matrices we can build. Some of these we've seen before, some of them we have not. So let's go ahead and take a look at some of these special matrices that MATLAB can build very quickly. We've already seen how to build a random matrix, but there are others, and so let's take a look at them. I think that we've built an array of all zeros before, but if we haven't, let's go ahead and do it. Build an array of all zeros. You just put zeros, comma, and you notice that we've got this little help box that pops up. That's kind of helpful because it shows you the different things that you can throw in there. I can build an array of zeros that is n by just plugging in a number. So zeros, parentheses, 7, for example, will give me a 7 by 7 array of zeros in a matrix. I can do the same thing with ones, and I can put in a number here and it'll give me, if I put in 9, it'll give me a 9 by 9 array, but I can also choose the number of rows and columns, so I can do 3 comma 7, for example, and I can get 3 rows and 7 columns. That's useful. Then I can use diagonal. The diagonal function, I put diag and then I put in some number 3, for example. It'll give me what is called a diagonal matrix, where nope. That's not what it does. Sorry. Diagonal gives me the so if I put in diagonal and I have a matrix like the previous matrix answer. There we go. So if I plug in, that's not helping me. I need I'm going to rename a matrix. A is going to be the matrix, let's call it the matrix ones, for example. Well, let's make a matrix of ones. So A is now the matrix of ones that's 9 by 9. There we go. Now I can use diagonal. If I use diagonal of A, for example, and notice that I can put in A, but I can put in some other things too. It gave me some options at some point here. Where were the options? Went away. But anyway, diagonal of A is going to return the actual diagonal of A. So it's going to create a new array of numbers from the numbers that are along the diagonal of A right here. Then you can also do the flipper. And I'm starting to think that I can't remember if we did these before or if I'm just remembering from studying this before. I just can't even remember because it's been such a crazy week. But I'm pretty sure we're supposed to be in this chapter today. So anyway, you can actually use the function flipper, and it will switch a matrix around and give you a mirror image across the center of the matrix vertically. So in other words, it makes all the rows flip their orders. The last thing in every row will become the first thing in every row, and it'll flip them all around like that. So what I'm going to do is build an array that's very simple here right now. I'm just going to build this array right inside this function, which you can do. So if I build an array inside the function that looks like this, 1, 2, 3, and then colon 1, 2, 3, semicolon 1, 2, 3, and I use the flipper function on it. Come on now. Okay. I need to actually make this matrix first, apparently, so let's cut that out. Let's call that B. And before we enter this in, I'll actually say B is, there we go, 3, 1, 2, 3, 2, 3. So now I've got a matrix here, an array of numbers, 1, 2, 3 in each row, right? And if I use the flipper function right here on this array, put in B here, you can flip things around. Come on. Oh, that's right. It's flipper with an LR, not flipper with a R. There we go. So it's giving me the proper thing, flipler. So flipler means flip left, right. It's just flipping from left to right. But you can also flipud or flip up down. Flip up down. You can do that as well to be. In this case, it won't do anything because the matrix is the same up and down. So that won't help us any. But anyway, it flips all the columns around essentially. And then you can create a matrix called the magic matrix. So I do a magic matrix of 4. This magic matrix is a matrix that is very unique, and essentially when you add up all the numbers in every row, you'll get the same number. I believe that's what the definition of the magic matrix is. Yeah, sums of all the columns are the same, and the sums of all the rows are the same. So if you add up all the numbers in any row or any column, you'll always get the same number. In this case, you get 16 plus 2 plus 3 plus 13. 16 plus 13 is 29, 31, 34. And then you get 16 plus 4 is 20, which is 39, 29, 34. 34, and you get 34 in every one. Now, this is kind of a goofy thing, but it's very interesting, but it doesn't really have any practical use yet. Nobody's really ever figured out how to use these in the real world, besides the fact that they're just kind of interesting. It was actually discovered hundreds of years ago, and mathematicians and scientists alike have been trying for years to try to figure out what kind of significance they could have, if any. And this is often done with mathematical curiosities. When we find something that's strange mathematically or interesting mathematically, we try to see if it has some kind of analog in the real world, and they often do. And that's when they become very useful, because then their interesting properties can be manipulated in mathematical ways, then we can understand the world around us better. So it becomes quite an interesting thing. So if you find a way to use the magic matrix to do something useful in the real world, make sure that you write it down and tell me, and then we'll go and earn a Nobel Prize together. Anyway, those are the things that we covered or supposed to cover today. And again, I'm thinking that we might have covered them already last week. I don't remember, but I didn't think so. I thought we covered something else, but I don't know. Anyway, if we did cover that, then I will find out soon enough, because I'm going to go and watch the video right after this, and then I'll make a new video later. So that's the end of that. Have a good day. Arrivederci.